Vanakkam. In this video, we are going to discuss about chemical equilibrium, its dynamic nature, and also the types of equilibria involving the chemical reactions. Okay, first we will deal with a small intro about. Okay, now let time be in the x-axis and the rate be in the y-axis. Similarly, we can draw another graph for representing equilibrium. Time in the x-axis and concentration in y-axis. See here, let A plus B start yielding products C plus D. After some time C plus D and combine, they react back to give the reactants A and B. To see here two reactions are taking place. One is forward reaction and another one is reverse reaction. See here, initially which reaction is taking place? So reverse reaction is 0 initially because C and D are not present. Forward reaction A and B are present. So initially while we are starting the reaction, forward reaction is rate of forward reaction goes on decreasing and it will become constant. Okay. Similarly, at 0 time reverse reaction does not take place. So this is the graph for forward reaction rate. Forward reaction, after some time it will reach the constant value. So this is the reverse reaction rate. So see here, what is the time? Let the time reversible reaction. Up to the time t, the reaction is a reversible reaction. And at the time t and after the time t, the reaction is called as equilibrium reaction. Because at time t only, rate of forward becomes equal to rate of reverse. Okay. So equilibrium means rate of forward reaction is equal to rate of reverse reaction. Right. Then coming for the concentration. Initially A and B are present. Let the concentration of A and B reactants be this one. So after some time the concentration of A and B goes on decreasing. I have already mentioned, when it reaches equilibrium the concentration is constant, then it will not change. So let the concentration goes on decreasing and after some time it becomes constant. This is the constant concentration. This means concentration of A and B for reactants. Concentration of reactants. Let it be for generally for reactant. Similarly, at 0 time there is no C and D. So the concentration of C and D is 0. With proceeding time the concentration goes on increasing and it will reach a constant value. This one. So this is the concentration of products. So they become constant at this range. So both the reactions, then up to this it is slowly decreasing. At this point it becomes a straight line. Parallel to x-axis. It implies at this time the concentration of reactants is this one and the concentration of products from this time the concentration of the products is this one. So up to this time the reaction is called as reversible reaction, and at that time and after that time it is called as equilibrium reaction. Okay, chemical equilibrium is referred as dynamic equilibrium because it is not static. Static means what? It is not attained saturation and it is always in an active state, or it is always in active state. How, sir? Because the rate of forward reaction is equal to the rate of reverse reaction. Rate of forward reaction is equal to the rate of reverse reaction. Hence it is called as dynamic. I will show you. See here it is off liter, here it is off liter. Water is moving there from the left to right and also from the right to left with the same speed. Hence we call it as dynamic equilibrium. How we know that, sir? Put a drop of ink on any one of the side. Put a few drops of ink, blue colored ink. After some time, the solution in this side also will become blue. It implies that water is continuously moving on both sides. Since the levels are not rising, it implies that there is a dynamic movement, that rate of forward reaction is equal to rate of reverse. We can experimentally prove this. See here, there is a cylinder in which there is equilibrium between hydrogen and nitrogen, which combines to form ammonia. That is an equilibrium, right? In another cylinder, I am mixing deuterium. Instead of hydrogen, I am mixing deuterium with nitrogen. I am getting deuterated ammonia, ND3. Right. Now, what I am going to do is, I am mixing all these two cylinders. It is present in one cylinder and it is present in another cylinder. I am mixing both the gases present in both the cylinders. Now, after some time, it is observed that ND3 is already present. ND2H, right? DH2, NH3, hydrogen, HD, deuterium, all these compounds are present. All these compounds are present, which implies that it is not static. Reaction mudinju pola, the reaction is continuously taking place. The reaction is continuously taking place. See here, HD, one hydrogen with a deuterium. One hydrogen with a deuterium is also present in the mixture. It implies that this takes place in this does not take place separately, and this does not take place separately. All of them, when they are combined in the same cylinder, all of them are mixed together, all of them are reacting, continuously reacting. So only we get all these products. So only we get all these substances present inside the equilibrium mixture. Clear? So it implies that the equilibrium is a dynamic one. It is not static. What is homogeneous equilibrium reaction and what is a heterogeneous equilibrium reaction? Homo, the word implies same. Geneous means phase, same physical phase. Then here different physical phase. For example, see here, hydrogen combines with iodine to form hydrogen iodide gas. All these are gaseous substances. So all of them are presenting same physical phase, same physical state. So it is termed as homogeneous equilibrium. Right? What is heterogeneous equilibrium, sir? Example, calcium carbonate in a closed vessel. It is a solid. It decomposes to give calcium oxide solid along with carbon dioxide gas. See here, in addition to solid phase, gaseous state is also present. So this type of equilibrium which involves more than two phases are called as heterogeneous equilibrium reactions. Okay, I think you are all very clear with what we discussed in this video about the chemical equilibrium. Then it is dynamic Y, then homogeneous and heterogeneous equilibrium. Clear? Thank you.